Alright guys, we're going to analyze inverses of exponentials and logs today. So let's look at the graph of our first function here. We have y equals 2 raised to the x plus 1 minus 4. So let's plug in some points. Let's find this graph right here, which is what this is right here. So if we plug in negative 1, we get negative 1 plus 1, which is 0. So 2 raised to the 0, anything raised to the 0 is 1. So 1 minus 4 is negative 3. If I plug in 0 here, I got 2 raised to the first, which is 2. 2 minus 4 is negative 2. And if I plug in 1, I've got 1 plus 1 is 2, 2 squared is 4, 4 minus 4 is 0. So I have these points right here, negative 1, negative 3, 0, negative 2, and 1, 0. So this is my first function right here. This is y equals 2 raised to the x plus 1 minus 4. Now what we're going to do is we're going to look at the inverse of that. So we're going to switch our x values and our y values. Alright, so this is going to become negative 3, negative 1. This is going to become negative 2, 0. And this is going to become 0, 1. So we're going to graph those points on this graph. So I've got a point at negative 3, negative 1. I've got a point at negative 2, 0. And I've got a point at 0, 1. So my graph of my inverse looks like this. So that's the inverse. I'm just going to say f of negative 1 of x. Okay, that's how we denote the inverse. Alright, so let's analyze our domain, range, intercepts, and asymptote. So for my function here, my exponential function, you can see my domain is all real numbers. My range goes from negative 4, which is the horizontal asymptote, so negative 4 to infinity. The intercepts, we have an intercept at negative 0, negative 2, and we have an intercept at 1, 0. Our asymptote is going to be at y equals negative 4. Now let's look at our inverse function. Okay, the domain of the inverse function. You can see that I have a vertical asymptote here for my inverse function. So the domain's not going to cross negative 4. So the domain's going to start at negative 4 and go to infinity. The range is going to be all real numbers. The intercepts, we have an intercept at negative 2, 0. And we have an intercept at 0, 1. And the asymptote is going to be at x equals negative 4. So let's look here. My domain and range are flipped. My intercepts have interchanged x and y values. And then instead of the asymptote being y equals, it's x equals. So what do we notice about our two functions? The x values are switched with the y values. Right? Those are interchanged. So this point negative 1, negative 3 became negative 3, negative 1. Right? So they just flipped. Alright, and what do we notice about the graph? The graph is reflected over the line y equals x. Now, how do I find my inverse function algebraically? What we're going to do is we're going to swap x and y. So right now this is y equals 2 raised to the x plus 1 minus 4. What we're going to do is we're going to swap the variables. So this is going to become x equals 2 raised to the y plus 1 minus 4. And now we're going to solve for y. So first step is to get rid of this minus 4. We're going to add 4 on both sides. We get x plus 4 equals 2 raised to the y plus 1. Now I need to get this out of the exponent. What I'm going to do is I'm going to take the log of both sides. So I've got the log base 2 of x plus 4 equals my exponent y plus 1. Now I'm going to solve for y. I need to get rid of this y plus 1. We're going to subtract 1 on both sides. So I've got log base 2 of x plus 3. So y equals, or I could say f of negative 1 of x perfect. Alright, let's look at another example. Alright, so number 1, let's graph this function. Alright, let's pick some points on the graph, So let's start with, how about 0? If I plug in 0 here, I've got 2 raised to the 0. 2 raised to the 0 is 1. 1 minus 2 is a negative 1. So 0, negative 1. If I plug in 1, I've got 2 raised to the first, which is 2. 2 minus 2 is 0. So I've got a point at 1, 0. Which are my intercepts. Let's go ahead and write those down. 0, negative 1, and 1, 0. And then let's plug in, how about 2? So I've got the point at 2. If I plug in 2, that's 2 squared is 4. 4 minus 2 is 2. So 2, 2. So the graph looks like this for my exponential function. So we know we have an asymptote, a horizontal asymptote at y equals -2. It's an exponential function, so the domain's all real numbers. The range goes from my asymptote to infinity. Now let's figure out the inverse of that, right? So I have a point at -1, 0. I have a point at 0, 1. And I have a point at still 2, 2. Let's find my inverse function. Okay, so here's my function. I'm going to switch x and y, so it's going to become x equals 2 raised to the y minus 2. I'm going to get rid of this minus 2, so let's add 2 to both sides. X plus 2 equals 2 raised to the y. Now I need to get the y by itself, so we're going to take the log. So log base 2 of x plus 2 equals y. So there's my function. I'm going to write right here y equals log base 2 of x plus 2. Alright, so let's plot those points. I've got a point at -1, 0. I've got a point at 0, 1. And I've got a point at still 2, 2. So my graph looks like this. Domain is going to be from my asymptote of -2 to infinity. The range is going to be all real numbers. My intercepts are flipped, so it's going to be at -1, 0 and at 0, 1. And the asymptote is going to be at x equals -2. Alright, let's review how to write these in exponential form or convert to logarithmic form. So this, again, log, if you don't see a base, the base is 10, so 10 raised to the second power is 100. 4 raised to the third power is 64. Alright, now let's go backwards, right? So the log base 3 of 81 equals 4. Or the log base 4 of 1 equals 0.